Assalamu alaikum. This is Walid Khashaba from ESS School of Science and Engineering, American University in Cairo. In today's session, inshallah, we will study fraction. Well, let's see what's meant by fraction. Here is the definition of fraction. It's the tangent force to the surface that opposes this body of moving. We have two types of fraction, the dry and the fluid fraction. Well, the largest fractional force is called limiting fraction. When the load or the force on the body comes to the maximum, to the fullest, or Fmax. Any further increase in applying forces will cause motion, will cause the body to move. F, of course, should be smaller than or equal mu s times n. What's mu s and what's that? F is the friction force, of course, and it should be less than mu s, which is the coefficient of static friction. He would provide you with this as a given in most of the questions. N, which is the normal, is the vertical force between surfaces in contact. Let's see some examples. First of all, we have two types of fraction problems. The first type and the second type. The first type is the impeding motion exists. The impeding motion exists when F, which is F max, equals mu s n. The second one, or the second type, the impeding motion is not known. We don't know whether the body will move or not. That's why we have two possible outcomes. The first one, if F is less than mu s times n. In this case, the body will rest in equilibrium. But if F was greater than mu s times n, in this case, the system is in motion. The body will to be moved because of the force. In this case, we will call it mu k. Mu k is the coefficient of kinetic friction. Anyway, mu k is about 25% smaller than mu s for any rigid body. Let's see the first example. Here we have a body which is 400 pounds, lying on a plane, an inclined plane, making 30 degrees with the horizontal axis, and there is a force acting on this body, 250 pounds, and here's the S and the K coefficients. Determine the value of the friction force, which keep this body unmoved. Well, there's N, of course, and N is the normal force, normal in this direction, normal of on the the surface N here, and as you know, there's a weight here. The 4 pounds is here. Well, we have to analyze this weight, which is 400, in these two directions. Well, summation of f of in the direction of y is 0, of course. We agreed on this. It's n, which is the positive, minus 400 cosine this angle, which is 30, like this, cosine 30. Then n is equal to 346.4. The summation of the forces in the x direction will be 250, which is to the right, positive, minus, right, 400 pounds in this direction. It will be 400 sine 30. Again, it's the same as this angle. So F will be 50. And now let's check whether the body will move or there is no motion. Well, mu s times n is 0.3 times n, which we have from this step, which is 364.4 times 0.3, which is 103.92. As you can see, this amount, this motion is greater than the force that we already have here, the friction force. So there's no motion, and the friction calculated is correct. Let's see another example. Here we have a bar, as you can see. It weighs 50 Newton. Determine the minimum value of the load P that initiate the motion. Neglecting friction at A because of this wheel, as you can see here, and he provides you with mu s, which is 0.5 at B, of course. Now let's analyze the forces. Here is the weight. It acts exactly in the middle. The distance here from the wall to the point B is 8. Then the weight here is 4 meters from the wall. Well, this is the first case. We know that there is no motion, and we need to calculate the maximum force, the maximum load can be act at P to initiate this motion. So this is the first case. Well, let's calculate the moment at A here. The moment at A will be negative n times the distance, which is 8. 0.5, this is the fraction, 0.5 n times 10, this distance, 10, plus P times 2. So we have this first equation, which is 3n minus 2p equals 200. Now it's time to calculate the forces in the y direction, because here we have two variables. So of course we need another equation in these two variables to be able to solve it together. The summation of the forces in the y direction will be n minus 50, which is the weight, minus p again, because it acts and acts down. Solving for p, then p is 50 Newton. So the maximum load can be act at this point is 50 Newton. Well, I think 2 examples is enough about fraction, and you need to solve more than 2 examples, of course. But I think this is all for today's session. I hope you understand what's meant by fraction and the two cases if there is no motion and if the fraction is unknown.